Okay. Hi all. I'm Inon Kostika, running product management, one of the co-founders at Wiz. First, thank you for coming to this session and to reInvent. Super excited to be here. And today we're actually going to cover how cloud security became AI security, and how are we thinking about securing the new attack surface that is now generated with AI. We have a packed agenda. I'll try to keep it in under 45 minutes and leave Q&A 15 minutes afterwards. But we're really going to cover first how did the attack surface change as a result of introducing AI, both from the blue side, from the red side. We're going to cover AI security with Wiz and how do we see organizations, customers actually securing their AI transformation. We're going to cover also how can we accelerate our security operations, our ability to detect faster, respond faster, and be one step ahead of the bad guys with the attack surface management capabilities that we've released, and also how we are introducing agents to our operating model to be faster than ever. With that packed agenda, let's start with basically how does the attack surface change? And what are the new things we should think about as we think about AI? And the first thing is really, does AI actually happen? Is it a real thing, or is it just a hype? The answer is based on surveys that we're doing times and again. AI is real. Your development teams are using it, whether you like it or not. Everybody's adopting it to the scale that almost every just one environment out of 10 is not using at least one hosted AI model. We're seeing that you have AI software that is hosted on your VMs, containers, also managed AI, all of the bedrocks of the world is being used across 80%, so roughly 80% of all cloud environments. So it's a real deal. And even if we look at the more, let's say, advanced AI implementations, agents, MCP, these are also in use already. For instance, MCP in use across more than half of the cloud environments today. Or this is one of the fastest adopted technologies we've seen historically, and it's amazing to see how fast organizations, businesses can actually bring it into their environments to make business value out of it. And from even the development perspective, 80% of all environments have at least one AI IDE extension. And more than this, even when you look at the GitHub application ecosystem, almost 20% already run an AI application. So this is to say that when we think about AI, it's not just people experimenting with some technologies. Across the board, AI is being adopted, and it's something that we have to account for when we think about our cloud security. Now, on top of this, also, the bad guys, the threat actors, are leveraging AI. And we're going to spend some time into how should we think about AI changing the way attackers are actually behaving. One thing that is relatively easy to understand is that like we are using AI in order to accelerate, be faster, more efficient in what we do, attackers do it in the same way. So if they want to create a phishing email, they can do it faster, better with AI. That's an easy example. But when we think even about stuff like weaponizing vulnerabilities, the time it takes to weaponize a vulnerability from the moment the CVE is released to the time you have an exploit ready can be automated dramatically with AI, and we're seeing sometimes it's down to hours, minutes, if it's a simple vulnerability, that you can actually get to a working exploit that you can start spraying. That's scary. It doesn't leave us with a lot of time for patching. It accelerates in reconnaissance. Instead of doing reconnaissance manually, we can automate it using AI. So there is a lot of acceleration that happens on the red side with AI. And in order to understand basically that the attack surface is existing and actually expanding, we launched recently a competition. I won't spoil it because we're going to run the competition next week at Black Hat Europe. but the competition basically has more than 20 technologies that are very commonly used within AI and cloud-native architectures, whether these are Kubernetes technologies, web technologies, AI technologies like Olaman, NVIDIA Toolkit, and basically we are asking for researchers to find RCEs on these technologies. Now, I will say that it's going to be very interesting to see the results. We've received numerous, basically, candidates for RCEs, but the more interesting thing, and it's really to understand that the vulnerabilities that are found are not only found in the components that we're using to build our AI applications and cloud applications, they're actually found through AI research. So AI is helping, this time the good guys, but in other cases also the bad guys, to find vulnerabilities in any software that we're using faster. So that's just to think about accelerating processes. And one of the other things that we've seen with AI is the emerging use of AI in malware. Now, this is like relatively novel. You can see examples. The first example, I think, was in LameHug. It was reported by the Ukrainian CERT. And this is basically a malware that got commands through and basically ran it as a prompt. So you can literally read the commands that the malware received. It's like plain English. Make a list of everything that you see, search for secrets, search for sensitive files, search for access to production environment, and also in the Amazon Q, basically developer extension attack that happened, it was also leveraged AI prompts on the device itself. The most recent example for it came in the Singularity attack, where basically through a supply chain vulnerability, threat actors were able to land on developer machines. And then you can see the type of prompts they ran on top of it, search for sensitive files, search for secrets that will gain them access to production environments to code. And this is just, and by the way, everything I'm saying is just the tip of the iceberg. We have fantastic research that is published on our blog, and you can really read through. This is like yet another research paper by Scott Piper. It really shows how malware is transitioning to simplify. So if you are running locally your agents, malware can use it as well. And our IOCs that used to be IPs, hashes, now become basically sentences in English that has a malicious intent, right? So that's what we start thinking when we think about a new attack surface, not just accelerating things we are already familiar with. So new techniques, we have what we call living off the LLM. I get to a machine, then it has agents. I can leverage these agents to pull, to basically move laterally, to pull, to do reconnaissance. So that's one example. Second one is using AI-related components, models, prompts, MCPs, compromise them. Having a malicious model on Hugging Face, so if someone downloads it and uses it, it infects an environment. And lastly, agent compromise. We have seen, again, recently, the Salesloft drift attack, where through the code of the agent, basically the threat actors were able to get keys, tokens to sensitive customer environments. And this is just to show that the attack surface now is not only accelerating because of the use of AI, it's actually expanding. Vibe coding is another great tool that is being used more and more. It's great. It allows non-developers to develop applications. It allows developers to develop faster. But one of the things we've seen, and that's again a series of research papers we've released, is that vibe coding platforms have some patterns in which they produce the code. And some of these patterns are vulnerable by design. For instance, you implement authentication, and the entire logic sits on the client side. Or you embed secrets or tokens, and then they are downloaded to the client side as well. And we're seeing these patterns. There are known vulnerabilities, but this time, it's actually the platform that generates it systemically into the applications. So we think about vibe coding, and this is, again, introduces a whole new area of risk. For instance, are the vibe coding platforms generate secure code, or maybe they have some systemic risk we have to account for? Like any other application, we generate an application, there may very well be vulnerabilities in it that we need to fix, non-systemic, endemic to the application we created. And the last piece, attackers can vibe code as well. So in the past, to be an attacker and develop attacking, like attack tools, offensive tools, required a lot of efforts. And usually they were generic and not very specific, but if it's very easy to develop tools, maybe I can develop a tool per attacker, per target, right? So I can become very targeted in how I develop vibe code, offensive tools, so I can get faster during attacks. So all of this, we're trying to map and understand all of these new risks and how should we be thinking about these new threats. And we came up with this quadrant model, and I'm going to spend a bit of time on it because I think it's important to understand that a lot of the things we see are actually related to an attack surface we already know. Code, secrets. These are things that were in use in attacks and will be used, but obviously threat actors can use existing techniques or new techniques to exploit it faster, better. The other thing that we're seeing is a completely novel attack surface, like the models, like now we have training data sets, but let's say training data sets in public buckets that are now exposed. This is an existing technique targeting a new attack surface. So the other dimension that we want to think about is whether it's a new technique or an existing technique. Are the threat actors using the same things, or are they inventing more stuff, new stuff that we need to account for? So when we think about the new stuff we want to account for, so the AI-powered malware is definitely a new technique, but it uses existing attack surface. And if you think about these 4 quadrants, this actually gives us a really good understanding on how should we think about our response to these attacks, to this new expanding threat landscape. First, on the things that are known techniques with expanded attack surface, we need to be really good in keeping up and improving the platform we use to create code. We need also to secure the code. We need to think about every single piece of code we generate and how do we secure it at the get-go, even if it was vibe coded. On the flip side, if we look at the new components, we have to extend our tooling into securing the new attack surface as well. So when we think about, okay, how do we secure AI applications, we have to extend our CSPMs, our CNAPs, to do AI-SPM. We want to protect AI as well. Same concept, extended to a new attack surface. On the novel techniques, this is really tricky. How can we face all of these novel techniques that are now being applied against us? So one, on the existing attack surface, always keeping great fundamentals is key. We have to scan better, we have to be faster, we have to implement fundamental security first. But then we also need to start thinking, how can we leverage in our defenses AI-based tools? So the AI-based tools will test us, will tell us whether we're doing a good job. So when we're actually scanning our environments, we'll do it with a new AI-enabled, let's say, view like the threat actors use. And then on the bottom right quadrant, that's where we're going to see a lot more innovation because these are really new threats. So malicious models, we had to come up with a concept to how do we scan models? How do we actually do it the same way that we scan containers? But we needed to build it from scratch. We needed to make it available. And same thing will happen across all of these new techniques on the new attack surface. That's where we're going to continue and innovate. But the good news is that the other 3 quadrants, we can actually secure it today. And we can work on it, and we can actually fortify our AI applications with the tools we already have. The last challenge is really about the visibility piece. And when we think about AI visibility, it's such a hard problem. And I want to spend like a couple of minutes explaining like why is it so hard answering a very simple question like where am I using AI in the environment? So first, what is an AI application, right? So you have the infrastructure that runs it. When we think about the infrastructure, you have containers, you have gateways, you have buckets, databases. These are the things you consume from AWS, other cloud providers on any application. So that's a CNAP layer, right, the infrastructure. Second, you have the new components, the model, the AI. You have the model, the training pipeline. You have basically where actually you're storing the data for the pipeline. You have the guardrails. You have the prompts. You have the MCPs. These are the new technologies that you're bringing into making, this is what makes it an AI application. And then you have the data component to it. Data is important from three different angles. One, what is the data that is the input from the outside? So what data comes and lives to the end user? What data was the model trained on? And then what data does the agent have access to? Because I can trigger an agent to go and pull new data, I need to be able to know what it is accessible to. So this is the third layer of AI. And then the last layer is actually the application itself. Where does the code sit? How is it exposed? How is it configured? And then only when you combine all of these four components together, this is where you're able to say, okay, I understand that I have an AI application, this is how it works, and these are all the components that pertain to it. Because as a threat actor, I can go at every single layer and try to compromise your AI application. And why is it such a hard task? Because do you know what other tool has visibility to all of these layers in one piece? That's why when we look at the CNAP, the Wiz graph, security graph, we feel like we have a really good understanding of where the AI applications live, how are they constructed, where are they running. And just to make it a bit more complex, it's actually a lot more complex, because I showed you a naive example on AI, but if you think about the decisions, the architectural decisions that developers can make in building these applications, so they can take the model, they can host it locally on a VM, on a container, they can use it as a PaaS from Bedrock, they can use it as a SaaS from OpenAI. They have multiple choices, and we, as security, we need to account for all of them. When we think about agents, same thing. When we think about identities, how do agents actually can perform tasks? They can get cloud roles, they can have applicative roles, and they can have SaaS roles. We need to account for all of these choices. So not to make it too complex, but we have a very hard problem actually understanding all of the AI applications that live in our environment so we can start securing them. And we spent 15 minutes covering around what is the impact on our attack surface, what is the impact that on both blue side, red side that we should account for. And just to summarize this, we think about 4 items, mainly a new technology stack that we need to secure, a new construct like agents that are operating in our environment, and then acceleration of 2 processes. Acceleration of development, so more stuff to secure, and acceleration of threat actors, and how they can weaponize and carry attacks against us. And now, to the silver lining, we have the tools to secure. Okay, so let's look at it in 2 ways. One, how do we extend the tooling we have to secure AI workloads? And second, how do we leverage AI to become better, faster in what we do, so we can be faster than the threat actors using AI? So let's look at AI security. We're going to do it in 3 sections. The first section is how do we use Wiz, CNAP, to secure AI workloads. Second, how do we use an automated tooling, like an attack surface management capability, to identify exposures we need to fix before others can find them. And third, how do we implement agents into our operating model so we become faster? So tackling the AI security challenge. First, we need to tackle shadow AI. If we don't see it, we cannot secure it. It's true, always true. So the ability to really map all of the components of the AI, it's really the key to start an AI security program. The second thing is mapping all of the infrastructure risks that we are already familiar with. If we know how to secure buckets from being publicly exposed, let's protect our training data sets so they won't be exposed on public buckets. And mapping it that way will allow us to actually use existing scanners, existing processes to secure our AI applications from the infrastructure today. And this is where we are actually seeing most of the AI-related AI applications-related breaches actually come from the infrastructure layer, not from the application layer. So this is like the first step that is key, second step that is key. And then we can layer on top all of the AI native risks. AI native risks like how can we secure the models we use? How can we assure the guardrails? And last, monitoring the actual activity on the AI application. There is a lot that we can do by monitoring AI, monitoring models, whether it's model escape, malicious behavior of an agent, and so on. And then we can monitor it live and detect threats as they happen. But there is a lot more we can do before that to prevent the threat initially. So let's start with visibility. We start with connecting to all of your cloud environments, to connecting to your SaaS environments, and connecting to your code. This is allowing us, across all of the development lifecycle, to detect the full breadth of AI that is in use in your development teams, in your production environments today, whether it's identifying SDKs in the code, whether it's identifying PaaS services, bedrocks used in your cloud, whether it's to identify training data sets, it's in buckets. More than this, today, we have GA'd the service catalog capability. The service catalog actually takes all of these components, builds them in a service catalog view. So you have an applicative aggregation of these resources. Every single service and all the resources it uses. And then you can have a very simple filter called, does it have AI? And you can go to the service catalog, it's automatically generated, scans your environment, and then you can filter what are all the services that have an AI component to them. And that's a denominator you're going to use across your AI security journey. This is a foundation. And if I am asking you today, let's say your CEO comes to you today and asks you, okay, give me the full list of all the AI applications in our environment today. Are we able to give an answer? Not so much, but through the service catalog, we start having a structure where we can actually identify and have governance around everything that is AI. And when we think about AI, so building this inventory will allow us to build a program, will also allow us to remove shadow AI. And I think the most prominent example for shadow AI, when DeepSeek was announced, almost 10% of all cloud environments were using it within a week. Within a week. And we were asking ourselves, and with our customers, how can we help customers really identify all of these new technologies and remove them from the environment if they are not approved? And that's why we have invested in these capabilities to create visibility so you can see the SDKs in the code, you can see the models in your cloud, and then you can put guardrails around what's to use and what not to be used. The last and very important point is when we think about AI, it's not only the application itself, it's also all of the pipeline that led to the model. So we want to know which training data sets were used in order to train a model. So the visibility doesn't go only to the app, it's actually to the entire life, the entire pipeline that created the model, for instance. Second, we take all of the scanners that we had. And we have scanners for identities to identify what are the permissions that are granted to agents. We have scanners on vulnerabilities, so we can scan models and AI technologies, SDKs, to see that they are not vulnerable. We can scan network access to see which ones are internet-facing. And we layer everything into the same graph. And we are also extending it with new scanners, for instance, scanning models for malware, for malicious behavior. So we start scanning everything that we do, and we layer it into using the same vulnerability scanner that you use, configuration. We have released dozens of different configuration posture rules that extend the CSPM to AI-based AI resources like Bedrock and SageMaker, so you can configure your cloud resources as you should. So when you're looking at your existing scanners, you should really make sure that they apply seamlessly to your AI workloads, to your expanded attack surface. And we have done it. So out of the box, you don't need to click anything for it. It just works. So we scan your entire environment, and we map it to the vulnerabilities, misconfigurations, exposures, lateral movement path of identities that are attached to agents, and also to the new scanners that we have launched. One challenge is really how do we account for the new platforms that are generating applications. And one of our partners, Lovable, in this case, it's one of the fastest growing vibe coding platform. And really, we did a lot of research with them on vibe coding security and what needs to be done. And one of the things we have just implemented is that any mutual customer can now basically see Wiz scans available in their Lovable portal. They can scan. The scan will be based on the same policies you are using for your code security today. So you have the same set of policies applied across vibe-coded applications and traditionally developed applications. And then you can see the findings of the code, both in Wiz, but also by the developers in Lovable. So we can start injecting the security mindset into the developed application, even if it's vibe-coded. So we standardized across vibe coding, traditional coding, and it's not such a scary thing anymore because we have our security guardrails applied. So that's a new integration that happens. And when we think about how do we prioritize all of this, because like any scanner, this will produce many misconfigurations, vulnerabilities, exposures, but we really want to know what do we need to focus on. And this is where the graph plays, as always, a significant role. We actually layer everything into the architecture we have built in the graph. We try to map this attack path. We try to find whether we have risk to the AI pipeline or to the AI applications. And the examples are just surfacing from Wiz through the graph detections we have, for instance. And these are all based on real examples. Externally facing MCP that has access to a cloud role. The cloud role has excessive access to data they shouldn't. Someone can literally ask the MCP to get data, and the tooling will do it. You want to avoid exactly these type of exposures, and you can do it using the graph. We can actually see from the exposed element to the application, to the identity, to the actual sensitive data that it can access. Same thing about exposing applications that have agents that have access to sensitive data, and they all surface, regardless of the platform, regardless of the implementation, through the security graph, so you can prioritize it to your development teams. And these are all things that happen today. Like, it's not roadmap, and these are things that you connect with, and you can start prioritizing these toxic combinations across your AI applications. Last but definitely not least, the ability to monitor the behavior of the AI and be able to detect whether you have actual malicious activity carried against it. So for instance, detecting malicious models or compromised models or model escape. So this ability is actually achieved by monitoring the environment on which the model runs, typically like hosts, and we have the runtime sensor that is now able to monitor models and detect these. We should also look at the control plane and identify, let's say, abnormal activity around your LLM resources, so we can identify LLM hijacking attacks that we see also in the wild. And these are all components that are related to our defend capabilities. It is really about monitoring your cloud environments, your runtime workloads, and detecting when bad things happen so you can respond timely and contain. So summarizing AI security in just a few steps. First, AI visibility, first and foremost. That's a foundation for your entire AI security program. Second, scanning for AI risks, whether these are the known risks, vulnerabilities, misconfiguration, whether these are new risks. Then we prioritize, we remediate the things that matter. There is a term coined by Simon Willison that is called the trifecta. Trifecta means that you can have input to an application with access to sensitive data, and it can respond back with the sensitive data. So we want to basically be able to block these type of toxic combinations, right? And this is what we do by prioritizing the issues in Wiz. And last, having the runtime monitoring on every AI workload so we can detect threats. This was AI Security 101. You can do it today with your Wiz environment. And second, this is a new capability we have just GA'd this week, and this is the attack surface management capability. I'm super excited about this capability. It's very different than how typical attack surface management tools operate because it is tightly coupled with our security graph. And I want to try to explain why is it so dramatic in terms of how we think about attack surface management to couple this external scanning with the deep understanding of the cloud architecture, the graphs, the security risks. First, when Wiz connects to an environment, the first thing we do is actually analyzing really good what are all the potential exposures this environment has. Whether it's a checkbox, somebody did make this serverless function public, make this bucket public, and whether these are applications that you expose through gateways, load balancers, and so on. Wiz maps all of this. We map public repos. And you can actually have a really good understanding of what's potentially exposed. Through the attack surface management capability, we are now automatically scanning them from the outside like a threat actor would do. And we're able to test, first, fingerprint. What is the technology that is exposed? Is it a database of this type? Is it a Jenkins? What is the technology? And then we are able to test for multiple different risks, threats against it live. So we get a qualified validation. Did you open, in this case, like a PostgreSQL with the default admin credentials? Did you have a Jenkins with misconfiguration that allows access to configuration files? Did you expose a resource with a vulnerability that can be exploited? We're doing these simple checks from the outside, and we are able to validate these risks. But that's only the first step. Typically, with attack surface management tools, you get the external finding, and now it's up to you to go try to triage it, find who owns this resource, where is it running, maybe it's in the cloud, so it's ephemeral, so it's gone, so who does own it? And then you have many questions on the triage that actually prevents us from automating the response to it, but not with Wiz. With Wiz, we have the entire story behind, under the cover. So we know which resource actually exposed this endpoint. We know what can it actually access. So we know whether it's a sandboxed environment or maybe the main way to your crown jewels in your crown jewel database. And then we're able to create an impact analysis saying this externally facing asset has a validated exposure and also a validated impact. So we can prioritize better, but more than this, we created the attack path, but we also know who owns it. Through our code analysis, we can correlate the cloud resource with the code contributors, and now we have an understanding of who owns the resource, who can fix it, and we can start automating the response in terms of ticketing, PRs, in order to get to the fastest resolution possible, because we know this is a ticking bomb. We know that if we were able to find this, the threat actors can, and the goal here is actually to create SOC-level findings for risks before it becomes an incident. And this is how powerful this tool is, but one thing is even more powerful. In order to enable it, it's a toggle. There is zero deployment, there is nothing. You basically have a toggle and you're done. It's going to scan your environment and going to surface the attack surface findings that matter so you can be covered today. So that's a very powerful way to get ahead of the attackers and become faster in how we identify these potential exposures and respond to them timely. And the third pillar that I want to cover is how do we use agents in our environment, in our security operations in order to be faster. And for years, since the day one at Wiz, we always talked about the cloud operating model. The tools, the technology is great, but the real thing that matters is are we able to change the way we are operating in order to really solve the challenge of cloud security. And we always talked about democratization, because if we were able to find the things that matter and democratize them to the development team so the development teams can fix them immediately, we're actually fixing the biggest bottleneck we had in security. So now the entire development community in our organization is working with us to secure our applications. So that was great. It allowed us also to shift left with preventive security. So once you have a developer, like a development team that sees how good looks like, but also how bad looks like, they are much more inclined to then implement guardrails into their development processes in order to prevent mistakes, risks from being introduced in the first place. And that's how we were able to introduce Wiz Code and actually shift all of the policies to the development experience itself, to the SDLC. So we are fixing it at the source when it's easy to fix and not afterwards. And last, after we have cleaned up the environment, we have better processes to deploy, to remediate, then it's a perfect time to bring in the SecOps. They can actually monitor the environment, they can respond to threats in the cloud environment, and they can grow their proficiency in what does it mean to really address, contain threats in cloud setups. So this was the operating model we've started, but the core of it, the foundation, was always the graph. The graph is a thing that allowed us to prioritize. It's allowed us to explain visually. You don't need to understand much about this implementation on this implementation. When you see an attack path, you see it, you're saying, okay, I need to fix it. Whether you are in SOC, whether you're in the development team, whether you're in security, you get it. But more than just humans, what we actually figured out, that if we can teach our agents to understand the graph, ask questions on the graph, they can actually become very, very powerful as well. They can become our colleagues, right? They can ask questions on the graph, they can get answers, and that's what we've been doing in the past year. So any agent is as good as a model behind it, and what's a better way to model security in cloud than the Wiz security graph? So the first thing that we've done, and this is something, maybe I should ask, how many of you are running like MCP with MCP today, implementing your own agents with a show of hand? Not too many. Okay, this is something you can do today. There are fantastic examples. Wiz has, so let's walk through the, let's say, history of applications. We used to build applications and we wanted to integrate. So we said, okay, it has to be API first. We did it API first. And now the next wave is you have to be MCP first. You have to make everything available through an external MCP server. So if you have a team that wants to know something, wants context from Wiz, they can just ask and they get it in their native experience. And that's exactly what the Wiz external MCP server allows you to do. It allows you to streamline the context from Wiz to any team, any persona you need. And we have fantastic customers that were really sharing how they did it. We have an example with Grammarly. Again, it's public. You can go on the website. Basically, Grammarly integrated into their SOC through the MCP server of Wiz context about cloud resources. They were able to achieve 90% efficiency, 90% reduction in time it takes to the SOC analyst to respond to threats in cloud, given the context they got from Wiz. So it's really powerful, and it's achievable today. So the first thing we would say in terms of extending Wiz to agents is use MCP to bring context, bring the knowledge from Wiz to any persona, any team that needs it. And you should ask it from any other vendor, right? It's not only from Wiz. You can correlate it with your threat intelligence agent, with your SIEM agent, with your ticketing system. So everything becomes part of your custom agents. And this is very achievable today. Second thing that we've launched is the SecOps agent. Now, when you are a SOC analyst, you get a threat. You start investigating it. You make queries in the portal. You use a graph to look for dependencies, relationships. And over the year, we've basically templatized how does a cloud threat investigation process look like. And we were able to create this knowledge base that says if you see this, then you need to look at all of these aspects. And we've done two things. We taught the agent how to query on the graph, but we also created, on top of all of our APIs, tools so the agent can use them. So that it can read issues, it can read vulnerabilities, it can read all events, it can read all of the context that a human analyst, SOC analyst, would read in the Wiz portal. And now, the thing we did is just every single threat that is triggered in Wiz Defend is automatically investigated by the Wiz SecOps agent. And we can provide the full investigation summary, but it's not just an investigation summary that is black boxed. It's actually using the same data that the SOC analyst can use. So it has 100% explainability. You can drill down to every single investigation step, ask why. It helps in both ways. We help analysts to understand what are best practices to investigate threats in cloud. But on the other hand, we can actually gain more inputs about we need to also to investigate this, we need to investigate that. So it allows us to learn as a team. And lastly, it provides a verdict. Based on this investigation, I was able to see that this is a common pattern. That's why last time you ignored it. So I suggest we ignore it as well. We can do it automatically. We provide like the real severity, or maybe it looks like a medium, but it's weird enough in order to trigger it as a critical. So it is able to provide a verdict. Is it malicious? Is it benign? Is it an automated test? And what's the true severity we think we should provide it? And that way, your SOC analyst, instead of focusing on 5 alerts a day, they can actually do 50. And this is really when we get a scale, and we're able to do not only addressing the threats that we see today, we're now able to do much more, to see much more through the mediums, through the things we rarely see. We can do more hunting. So we have a lot more opportunity to extend the horizon than just dealing with false negatives, right? And then the third pillar is a remediation agent. The remediation agent is key in order to understand how to fix an issue. Today, when we trigger an issue, you see the attack path, and typically you go to the development teams and they know, well, we shouldn't touch here, maybe we should fix there, this is not in use, maybe we can just, shut down the public exposure, maybe we can trim the right-size the permissions because it's not needed. It's a lot of knowledge that is not written anywhere. The development teams know it because they know it, right? They know the application. But we have the knowledge, and we can sequence these questions for our remediation agent to basically see whether a public exposure is actually in use or not, whether permissions are in use or not, whether a resource can be remediated without impact on the environment, whether there are dependencies or not, whether this bucket is click-opt from the portal, so you can do the fix directly in the CSP portal, or whether this bucket is actually a result of a cloud formation or a Terraform file, and you should apply the fix in the code. And we know who is the developer, and we can actually create the PR. So basically, the remediation agent is analyzing the ownership, what is the impact analysis, the attack path, and what's the best course of action to remediate a certain issue that is identified by Wiz. So MCP, the SecOps agent, and the remediation agent are all available for you to integrate today and accelerate dramatically your cloud operating model using these agentic capabilities. And I know I covered a few different areas, but it really comes down to the model we discussed earlier. How can we extend the CNAPP to secure any type of AI workload that is now created in our environment? How are we able to accelerate the detection of exposures, threats, before automated attackers would do it using ASM? And third, how are we able to accelerate remediation response using agents within Wiz? And these are all the capabilities that were launched actually recently, you can use today, that feed exactly into this winning AI with AI model where, yes, there are new challenges that are introduced, but yes, the tooling we have today, the processes we have implemented for cloud security are robust enough in order to accelerate, in order to support this new technology stack that is introduced, these new challenges. And we're confident that as we continue to implement, we will be able to securely enable AI for your businesses, for your developers. And with that, this was the tip of the iceberg in terms of what Wiz can do. We will be super excited to show you like a full demo, answer any questions in our booth, 1447. And just reminding, Wiz is a platform. We covered a lot of the
capabilities. Wiz Code secures the code. Wiz Cloud analyzes your cloud. Wiz Defend is for SecOps team, monitoring, responding to threats. So a lot to show there. We are a platform to actually secure the entire cloud development lifecycle. And with that, I really want to thank you for the session. I'll be here for any questions you may have or in the booth. And thank you very much. Enjoy reInvent.